Hello, can you hear me?
Yes.
How are you guys doing?
Fine, and you?
Fine, thank you. So let me take down these names and then we'll begin right away. Okay. Else. I have it. All right, let's begin. Today we're looking at regression and correlation. And before we start, I would like to let you guys, I think I made an announcement already. I have extended the due date for the project, so you have more time to do it. Okay. Now, correlation and regression, that's what we're focusing on today. Okay, people here. What I'm seeing is not 12. Give me one, let me put this in Johnson. Who's Johnson? Who again? Johnson. Oh, got it. Who else? Who else? Who else? Who else? Okay, I got it. Okay, let's continue. Now, correlation and regression. Correlation simply means the statistical measure that indicates the extent to which two or more variables move together or fluctuate together. So in regression, what we do in regression is to determine the strength of the relationship between one variable and the other. One of the variables is called the dependent variable. Then the other one is called the independent variable. So in regression, we try to determine the strength of the relationship between one variable and the other variable. One dependent variable and the other independent variables. So that's the main thing we do on correlation. In regression. Now, but in correlation, we try to describe the degree to which two variables move in this together. Now, we use these two concepts a lot. For example, a business owner might want to know whether the volume of sales for a given month is related to the amount of advertising that they did that month. Educators can also determine whether the number of hours a student studied is related to the score the student has in a particular exam. In medicine, we use it as also in medicine as well. For example, medical researchers might be interested in answering questions like, does old age affect blood pressure? So you can see we use different scenarios. We use correlation and regression in different situations. Now, let's look at the variables we are talking about here. The first one, we call it the dependent variable. Now, the dependent variable refers to the variable that the researcher or we can control. No, we cannot control. So we call it the dependent variable. We also call it the y variable. We cannot control it. So either you call it the dependent variable or you call it the y variable, or you can call it the response variable. Now, for example, things like total sales, we have no control over that. I mean, we can spend money on advertisement, but what is the amount of sales that will result from those advertisements? We have no control over that. So it's called the y variable or the dependent variable. Another example is good health. Now we know that I mean, from what we read from the magazines and from what the health authorities tell us, exercise give us good health. Now, so if you exercise so a number of hours each day, what is the quantity of good health you're gonna receive? You don't know. Some people might do the exercise over time, and then their health to be robust. Some might do it. It may not be that strong. They might even get sustain some wound injuries through sprain and other things. So you cannot control really how much good health. I know exercise promote health, but what is the quantity of robustness that you get or to get from doing exercise? You have no control over that. You cannot control it. So we call it dependent variable. Okay. Now, for the independent variable, even the grades can be part of the dependent variable. For example, you might study certain amount of hours each day, but what I know is those studying make you to have a better grade. But how much? What is what was the percentage of the improvement in your grade that the amount of time you put in studying can result to? You have no control over that. The independent variable is the x variable. That one we have control over that one. And we can control it, we can manipulate it. For example, we can decide that we're gonna spend $1,000 in advertisement. See? And we spend it. We have control over that. Now, also, we can decide that, okay, we exercise only 1 hour each day. See, we have full control. So that's because we have control over it. We call it the independent variable or the x variable. Some people call it the predictor variable. Now, you can now review more concepts under correlation and regression. The first one is the correlation coefficient. The correlation coefficient. I'm supposed to make this a subtitle of itself. The correlation coefficient. Now, with this is the measure. This is the numerical measure of the degree to which two variables move together. So, the one we'll be calculating, there are different types of the correlation coefficients. But the one we'll be calculating for this class, we're using for this class is the Pearson product moment correlation coefficient. And if we use R to present that, R is the sample correlation coefficient. So at this point, we now want to look at how the range of values of the R. It ranges from -1 to +1. You can see the chart right here. 0 means that there's no relationship. If it's closer to 0, let's say 0.3, that means it's a weak relationship. It is closer to 1, it is strong. The same thing on the left side. If it's closer to the 0, it's weak. But it is closer to the -1, it becomes stronger. So on this side, I have negative correlation and a positive correlation. Okay. And this is how we interpret it. If the correlation coefficients are is fall within 0 to 0.2, we say that it's very low, and that the strength of relationship is very low. If it is from 20 to 40, the strength of relationship is low. If it is 40 to 0.4 to 0.6, it is moderate, and so on and so forth. Now, we also use what is called a scatter diagram to show the relationship between the two variables, like x and y variable. So a scatter plot is simply a visual way of describing the natural relationship between the x variable and the y variable. Also, let me put it this way. It is a visual way of describing the nature of the relationship between the dependent variable and the independent variable. So when you plot it, if it's going up like this, we say that we have a strong positive linear relationship between the x and y. If it's trending down like this, we say that we have strong negative relationship between the variable x and y. If it is scattered like this, with no pattern, we say that there is no relationship between x and y. There's another concept we call the correlation coefficient, the coefficient of determination. The symbol we use for it is R squared. So this measure explains how much of the variability of a factor can be caused or explained by its relationship with another factor. So you can tell us how much of the change in the y variable is caused by the change in the x variable. Now, we can now look at regression equation. So this usually we have it in this form: y equals b0 plus b1s, where b0 is the y-intercept and b1 is the slope. Now, to calculate all these things that I mentioned, we make use of these formulas that I have on the screen. You can see the formula on the screen. So you can see the one for calculating sum of square. Then to get the correlation coefficient, to now use this final form, combine the result from using all these formulas here. Now, what I have said so far, does anybody have a question? Okay, no question, good. Now, using these formulas will take you a long time to calculate coefficients. So we'll be using Excel to do it. Excel simplifies the process to work and also every other thing that we need to get. Now, otherwise, you can use the formula this one, a complicated formula to use. It might take it with, I mean, it's interesting to explore, but it will take you a longer time to use it to finish the question. But with Excel, you can finish the question in a very short time. Let's try one example. If this here says, in a random sample of 9 steers, the live weight and the dressed weight were recorded. In the table below, we let Y represent the dressed weight. You can see the dressed weight in hundreds of pounds, and S denote the corresponding live weight in hundreds of pounds. So this means that they said they're in hundreds of pounds. That means 4.2 means 4,200. 3.8 means 3,000. Actually, it means 420, not 4,200. 420. This one means 280, 250. So I remove the 2 zeros. Anyway, the question was use the sample data to obtain the least square estimates of the regression equation. That is me asking you to find the regression equation using the least square estimates. Well, we are using Excel, so Excel will give us what we need. So calculate the correlation coefficient R. Calculate the correlation coefficient R squared. Draw a scatter plot. So I'm going to add one more thing. What is the value? Say find. Add one more thing to it. Find the dress weight the dressed with X when the live weight if Y, but live weight is 10. So find the dress weight is Y, not X. Find the dress weight X when the live weight X equals, let's see how was it up here, 5.5. So I'm gonna save this. Okay. So let us do this. Okay. Again, the first thing to put this in Excel, this information in Excel. So I'm gonna copy this from here. Okay. Copy this, open Excel, and then put it in Excel. Okay, well, paste it right there. This side represents this side represents the dried weight, live weight, and dressed weight. Okay. So how when we say dressed weight, actually the weight after the meat have been boned and then packaged. Now let's go to the Excel and then get it done. Okay, live weight here. This one is dress weight. Okay. Dressed weight. Wait. Yeah, I'm going to make this expand them so it will be legible. Okay. We have a live weight and dressed weight. Now, the question says we have several questions to answer in that question. It says use the sample data to obtain the least square estimate of the regression equation. Now, as you know, the regression equation goes this way. Y equals BO plus B1X. So now let us get the output from Excel, and that we'll be able to answer that questions. So the first thing to do is to go to your data analysis section. Okay. Give me 1 minute, make sure you're seeing all this. Excel, okay, good. So you go to your data analysis section, you can see that you click on data first. So click on data analysis. Now, you're looking for doing regression. So you go to regression. See how you have it, you see where you have regression right here. Click on it, click OK. Then for input range, for Y, input Y range, Y is the dressed width. Highlight that, select this data set, including the title, the label. Then add input range X variable. Okay. So you go and then select the X, which is the live weight. Okay. Now select labels because I included the title, so I'm going to select labels. Then output range. I want the output to be placed below it. Output should be placed below it right here. Okay. Then I need line of fit plot. And what else do I need here? Yeah, I think that's it. Then I can click OK. So it gave me the result plus the graph. Okay. So I'm gonna see your the result and the graph. So now, from this result that it gave us, we can get our answers. The first thing they asked us in that question was to use the sample data to obtain the least square estimate for the regression equation. That is, find the regression equation. Okay. So now here we have our we need our B1, B0, and B1 because they are in the formula. I see them right in the formula right there. So yeah, this is a small b. Okay. Once we have them, we can now get our regression equation. From the what we have from the output we have in the Excel, we'll see that this is the B1 right there. I'm gonna highlight it so you can see it. The first one is the B1, second one is likely, which is the B2. First one is B0, second one is B1. So let me write them down. B0 equals 0.08. You can see B0 right there. 0.08. Since we can just do let's do it 3 decimal places, make it easy for us. Reduce it to 3 decimal places. Oh, excuse me. So 0.086. And B1 is the second one, which is this one here, 0.616. So we can now go to our workbook and enter these numbers. PO 0.086 and B1 0.616. I believe that's what we have there. Let me double check it again. Yep. Okay, so with this, we are now have our first answer, the regression equation, so that the regression equation now becomes plug these two numbers here. Have y equals for BO, we write 0.086 plus B1 is 0.616. X. Now, there's something we need to put there as a caution. Let's look at the graph that he gave us. That will help us to figure out find out the sign of the B1. So you can see that it's trending up. The rest we see is going up. So that means it indicates a positive linear relationship. So that that means that our B1 will be a positive number. So right now, it's a positive number right here. Now, how do you interpret this? How do you explain this? See that B1 is 0.616. Remember, this is life weight and rest weight, and they are in hundreds. So what does this loop of 0.616 mean? According to it means that the slope of 0.616. Okay, I wanna make this. Okay, let me make it unbold it. Okay, this indicates that indicates that remember the y is the dressed weight. So indicate that the dressed weight increases or changes. I say increases because it is a positive slope. If it's negative slope, it means decrease. Increases over time at the rate of 61.6 pounds for each 100-pound increase in the life weight. Okay. Any question on this one? Any question? Okay, there's no question there. So now let's look at part 2 then. Part 2 say calculate the correlation coefficient R. Okay, part B. The correlation coefficient correlation coefficient R equals, we can get that straight from the Excel output. Given that this graph is trending up, that means it is positive. So these are R here. You can see where you have multiple R. So I'm going to make all this and make them to be two decimal places. So you see an R right here with the multiple R. That's our R. 0.95, which indicates a strong positive relationship. See, 0.95. So how do we interpret this? Interpretation of this. Yeah. The R value of the correlation coefficient, the correlation coefficient, you have R equals to 0.5, indicates a strong positive linear relationship between the dressed weight and the life weight. Okay, so what does this mean? When there's a positive relationship, that means when one variable increases, the other one also increases. Okay, it mean that when one variable increases, the other one increases. So, but if there's negative relationship, it means that when one variable increases, the other one decreases. So in this case, there is a positive linear relationship, and it's strong at 0.95, which means that as the life weight increases, dress weight also increases. As the life weight decreases, dress weight also decreases. Any question on this one? Any query? Yeah, excellent. No question. Good. Now, part C says, calculate the coefficient of determination R squared. So let's put it. Part C, you say calculate the coefficient of determination R squared. That one is, again, we have it from the output. The coefficient of determination okay, of determination R squared, 1 minute, very weak. R squared is determination r squared equals, let's see, I'm gonna make it make this in square. Okay. All right. We can find that from our output that we generated from the in Excel. You can see right here r squared. So when I highlight it, use a different color. Probably green. It's 0.91, 0.91. So you can go and put it there, 0.91, 0.91. So what does it mean? Interpretation of this. So the coefficient of determination of r squared 0.91. Okay. Make this one bold. Okay. The coefficient of determination r squared which is 91 means that 91% of change, 91% of the change in the dressed weight is caused by the change in the life weight. What it means? Questions on that? We have question, always ask. Any question on this one? Okay, good, excellent, no question. So let's look at the next question. It says, draw the scatter plot. Say, draw the scatter plot. Remember, that one was one of the things that the output gave us, the scatter plot. It gave us the scatter diagram, and it's right here. You can see right there. Life weight line of fit plot. So you can just copy it. Since it's already drawn, you can just expand it. Okay, remove all this here so you can have enough. Yeah, see, and then you can just click here, press Ctrl+C to copy it, and then went to that section where it asked, the equation was asked, and paste it right there. So I'll have our scatter plot part D. Okay, you can see the scatter plot right here. You can see that as life weight increases, dress weight also increases. You can see the linear. It shows a strong, positive linear relationship between the life weight and the dressed weight. And then the final question there is to find the dress weight Y when the life weight is X is 5.5. Yeah. In that case, you're going to use the regression equation to do that. Part E. So put the part E right here. So part E again says to find the dress weight Y when the life weight is 5.5. So when S is 5.5, okay, when X equals 5.5, then the dress weight Y becomes equals 0.086 plus 0.616 times times for this, plug in 5.5 for X, 5.5. So you can get this result from, get a calculator. I think I have this page so I can put that there. This most. So I will write this down so we can solve it. So we have what you have here is the equation where the X will be plugged in. So we have Y equals 0.086 plus 0.616 and 5.5. So when you plug this in, the you plug this in the put in the calculator. Yeah, we're gonna have this. We have 0.086. Okay, plus then put 0.616 times 5.5. 3.474. I think that. I mean 3.47 rounded pounds, which actually means 347 pounds. So let's put it right there. Okay. Good. So write it right there. 3.47. So remember, when I wrote the equation, I was telling I mentioned that all the others are in hundreds. So we have that 3.7. That means that in the interpretation of this, so you have that the dress weight is 347 pounds when the life weight X equals 55 pounds. Actually 550 pounds. 550 pounds. Any question on this? Any question? So you're gonna see this in your next homework, where you should be ready on Monday. It will be ready on that date. And then we'll come back on Monday, we do more examples of this. Now, for those of you who doesn't know yet, I've extended the due date for your project to next Sunday, so you have more time to work on it. Before we leave, any question?
Can you post this Zoom?
You want this posted?
Yes, please.
You mean the notes, right?
The notes.
I mean, you want this notes? Want me to upload it?
Yes.
Okay.
Yes.
Okay.
Thank you.
Okay, let me save. You're welcome. Let me save it then. All right, then. Let me leave you so you can go and continue with your project, and I'll see you on Monday, okay?
Wait, I have a really quick question. Will we also be getting this video for reference to look back at?
Oh, you want the video too?
Yes, please, if possible.
Okay, I will put it there too.
Thank you. Have a good one.
You too. So let me save.
Have a good one.
You too. I'll see you guys on Monday.
See you Monday.
Sure.